You are welcome to today's class. Today we are going to be looking at advanced variance analysis. Okay, the knowledge you've garnered under variance analysis will help in this topic. So we have 4 subtopics that we'll be examining: mix and yield variance, sales mix and sales quantity variance, operational and planning variance, market share and market size variance. So mix and yield variance. Now you know material usage variance that we discuss in variance analysis. Material usage variance measures the difference between the standard quantity minus the actual quantity times standard price. Now, what of if there are 2 or more direct materials in the company? How do we get their material usage variance? To get their total material usage variance, we now have to compute each and every usage variance for each direct material and sum them up to give us total material usage variance. We did this here. When we look at these calculations, we say product X is produced from different direct material A, B, and C. So there are 3 direct material that we can use to produce product X and that are mixed together in a process. The following information relates to the budget and output for the month of January. So we now have standard costs, actual. So we have material quantity, standard price per kilo, standard cost, quantity used. So this section, you can say it is standard, while this section is actual. So for product A, B, C, the standard quantity per unit is 118. So for material C, it is 8. For material B, it is 1. For material A, it is 1. The standard price are 20, 22, 6. The standard costs are 1 times 20 will give you 20. 1 times 22 will give you 22. So we'll continue. Now, to get the usage variance, the formula for calculating material usage variance is, look at the formula. Standard quantity minus actual quantity times standard price. And there are 3 direct materials, A, B, C. So the standard quantity will now be 1 kilo for material A times the actual finished goods. That will give you 200. For material B, 1 kilo per unit times unit produced, that will give you 200. For material C, 8 kilo per unit times 200, that will give you what? 1,780. Sorry, 1,006. So you substitute it here: 200, 200, 200, 16. So yeah, you know how it was gotten. The actual quantity will now be gotten. Now in the equation, this is the actual quantity. 16, 180, 1760. So when you substitute, you have this 160, 180, 160, 180, then 1760. Then how did you get your standard price per unit? Standard price per unit now be standard price per unit will now be, look at it, standard price per unit. Standard price per unit. So in this standard price per unit, A is 20, B is 22, and C is 6. So you go back, you substitute for A, you substitute for B, you substitute for C, multiply through, it will give you this. So how do we get it? $200 minus 160. I told you if it is positive, it is favorable. If it is adverse, it is not. It will be negative. So 200 minus 160 is positive. So it's favorable. So you put favorable here. 200 minus 180 is favorable. You put favorable here. 160 minus 1720 is adverse. So you put adverse here. Why is it adverse? Because it is negative. So we add together. What do we have? Sorry for that breaking down in transmission. So we continue. So we have 800 plus 440. You add the favorable and less adverse. That will give you 1240. 1240 minus 960. 1240 minus 960 will now give you 280. And this 280 will be favorable. So we have 280 and it's what? Favorable. So that's the total. This individual computation of material usage variance for the three direct materials can be ascertained using fixed, especially using mix and yield variance, especially where the direct material are substitutable. So we can now compute material mix variance using that same equation. So now, this measures how much of the usage variance is attributable to the fact that the actual mix of the red material were more expensive or less expensive than the standard mix of the red materials. It measures the effect, the change in proportion of actual and standard units in relation to standard cost per kilogram of the red material we have we have on direct material usage variance. So using that question to calculate our mixed variance, the formula is actual quantity at standard mix minus actual quantity at actual mix times standard price. So you do it individually for the product. So the actual mix is this: 160, 180, 1760. Look at it. At least I know you can remember. Look at it. Actual quantity used: 160, 180, 1760. So we'll now come back. That is why it was represented here. Now, the standard mix will now be actual quantity at standard mix. Actual quantity at standard mix. How do we do it? Now, you have to first of all, find the proportion. That's the first thing you do. The proportion of standard mix, which is 1 over 10. 1 over 10, or 8 over 10 will give you 10, 10, 80%. Now, looking at this, you would notice that this will now be standard mix on actual quantity. What is the actual quantity used? The actual quantity used is 2,100. So it will now be that standard mix that I have calculated. That you can see it. This standard mix will now be applied on the actual quantity used. Applied on the actual quantity used. So 2,100 times 10% will give you 210. To give you 210, will give you 210. Now 8% times this, 8% times will give you 1680. So we have 1680. So this minus this, so 210 minus 160 will give you 50. 50 times 20 will give you 1000. 210 minus 180 will give you 30, and it's favorable. 30 times 22 will give you 660. Now 1760 minus 1780. 1760 minus 1680. That will give you 80. 80 times this will give you 480. So you can see 50 is favorable. Why is it favorable? Because actual is lesser. You understand? Then where we have adverse, actual is more. So when you multiply, you have this. If you add up, you have this. When you add up, you have this. So 1180, and it is favorable. That is how to calculate your material usage variance. It's very, very simple. So just put all your actual mix here. Standard mix will be based on proportion. And that proportion is this. How do you get 1 over 10? It is this 10 here, the 10 here. 1 divided by 10 for A will give you 10%. 1 divided by 10 for B will give you 10%. 8 divided by 10 will give you, for C will give you 80%. So that is how it was got. You now apply it on the actual unit. That is why it's called standard units. So the standard quantity, standard mix on actual quantity. So this is the actual quantity used, and the standard mix is these ratios. And our actual quantity and on actual units is all this, which will still give you 2,100. So we'll now look at direct material yield variance. Now, this measures how effective we are able to use the material mixture to give more output than expected. That is the effectiveness of standard mixture to produce more output. You understand? The formula is simple. Standard quantity as standard mix minus actual quantity as standard mix. That is just how simple it is. Now, the standard quantity and standard mix and the actual quantity and standard mix. It is very, very simple. I think I would prefer to use material than to use product. Now, the actual quantity is 2,100. You understand? Why actual the standard mix on actual quantity is 10 on 200. So we'll now come back and finish this off. So the actual this become actual mix. This become actual mix. Actual mix. Look at it. Actual mix. Are you there? Actual mix at standard mix. Actual mix at standard quantity. That'll be actual quantity at standard mix. Or to just make it easier, I'll just call it actual quantity. Actual quantity used for material is 2,100, while standard quantity is to make it easy will be bracket open. That will be 10 units multiplied by the actual units. 10 is the standard mix multiplied by the actual units produced. So that will give you 2,000. That will give you 2,000. So we have 2,000. So 2,000 minus this will give you 100. So you would observe something here. You'd observe that the actual is 210 and the standard is 200. So actual is higher. So we have difference that is 100, and this difference is adverse. Are you there? The difference is adverse. So since the difference is adverse, we'll now come down and get our weighted average price. How do we get this weighted average price? Let me show you something. To get the weighted average price, it is total standard cost divided by total standard quantity, which is what? 90 divided by 10 will give you 9. How would that make sense to you? So we now come 90 90 divided by 10. 90 divided by 10 will give you 9. Will give you 9. So divide this by 9 and multiply this by 9. When you multiply this by 9, remember it's 9 naira. When you multiply this by 9 naira, it will give you 900. It will give you 900, which is the same answer we got before. But I just prefer to use this because it make more sense, it make more sense. That is why I prefer to use it. So with this, we can actually say that we have computed yield variance. So yield variance is very simple. Your actual quantity, which is what? Which is 2,100. Then to get your standard quantity will now be 10 standard units per unit, 10 standard kilo per unit times actual units produced, which will give you 2,000. So that is how this 2,000 was gotten. That is how this 2,000 was gotten. So 10 times 200 will give you this. So the difference will give you 100. So you interpret whether it is favorable or adverse. I've told you how to do it. If actual is higher, it is adverse. If actual is lesser, it is favorable. So you multiply by 9, you have 900 and it is adverse. Hope that makes sense to you. So with this, we are good to go. So now I have another question which you shall look at. It's an assignment for you, although I also provided the answers. So look at it and appreciate it. In our next class, we'll be looking at sales volume, mix, and quantity variance. Thank you for your audience.